Hello everyone, let us get started with C++ certification training. The topics that we are going to cover under this discussion is that what is inheritance, what are different types of inheritance, what are the advantages of inheritance, hex overview and implementation of Tic Tac Toe game. So let's begin our discussion with looking at what is inheritance. So what is inheritance? Inheritance is a concept where a subclass gets all the feature of an existing base class, which improves reusability of existing code. So what it means is that, let's say you had a class, let's say this is a car class, CAR, and you want to create a specific kind of a car. Maybe it could be a BMW car, for example, or Maruti car, right? Now, if there is already an existing functionality in car, which can be used by BMW or Maruti, we should inherit the car class, or BMW should inherit this and Maruti should also inherit it. That is what it is trying to say. This is a concept where a subclass gets all the feature of existing base class. So if something is already there, let's get all the features. Now, inheritance provides a method for creating new classes from existing. So these are the new classes. This is an existing class. Creating, for example, you create a scientific calculator from existing simple calculator. So in case you had a simple calculator which was performing basic operations of adding numbers, multiplying numbers, now you want to create a scientific calculator which can calculate square root and other complex functions as well. So you should not rewrite the entire scientific calculator class from scratch. You can create a scientific calculator class and it can extend the existing basic calculator, and then you can continue to add the new functionality. So these new classes contain the data and behavior of existing class. So when we do inheritance, whatever is there will become part of the subclasses as well, the members, which is the attributes and methods. And also it allows us to reuse or inherit data and behavior that already exist, as I just said. Now the superclass is known as base class and subclass is also known as derived class. So you get to use what is already there here, plus additionally, you can add more functions and attributes here. So the idea is that you take what is existing, use it, plus add more features. This is a concept of inheritance. And syntactically, this is how it looks. We will try it out with an example in some time. So you can say class, name of the class. Here you specify colon, then you specify access type and the name of the superclass. So this is a subclass and this is a superclass with respect to inheritance. So let's take a very simple example to understand what is inheritance. Similarly, we may have different types of shapes that we can draw, such as line, oval, circle, square, and so forth. Depending on our application, we can identify common attributes that all shapes have, for example, color. So let's say I have this hierarchy in place where I have a shape, and there can be different kinds of shapes here. So I can define a method color, and this color is a method which gives colors to different shapes, that is the subclass of the shapes class. Now, since this method could be commonly used by all these subclasses, smiley, cone, and star, so a good idea is to basically inherit the existing shape class. Smiley is also a shape, cone is also a shape, star is also a shape. So we can reuse what is existing and then additionally add more feature in this individual subclasses. So syntactically, this is how it will look. There is a class shape which is existing. Then we say class smiley, colon, public, and shapes. Same way we do it for the other subclasses. So this is how we basically make use of inheritance. Syntactically, don't worry, we are going to try out all of this with some examples in some time. Now let us talk about different types of inheritance. So we have single inheritance, multiple inheritance, hierarchical inheritance, multi-level inheritance, and hybrid inheritance. So these are different options or different types of inheritance that are available in C++ programming. Depending upon your need and your requirement, you can choose to use any one of them which suits your, or rather which solves your problem statement. So feel free to use which one solves your problem statement. So let's move on. So what is single inheritance? So single inheritance, as you can see, the process in which a derived class is inherited from only one base class is known as single inheritance. So you have only one superclass and one subclass. Simple syntax is you create a class, you create a subclass, and this subclass extends the superclass. So therefore, since this is a public member, this will get inherited and will be available in the car class. Now, as far as accessibility of the members in the superclass is concerned, we have already discussed this concept in details in access modifiers in other modules. But as of now, please understand that in single inheritance, there is a single subclass and a single superclass with respect to the concept of single inheritance. So now let us try to understand the concept of inheritance with the help of some coding examples. So for that, I will head over to my lab VM where we'll try out some of these examples. I already have a class vehicle and I have a public constructor and a method here, as you can see. Now this class starts here, this bracket, and ends here with a semicolon. Similarly, I have one more class with a constructor and a method display car, and this is display vehicle. Now, in order to do inheritance or in order to implement inheritance, what I have to do is, as you can see here, syntactically, I'll say car colon public and then the superclass name. So let's do that. So what I'll do is I'll say car colon, I'll specify access modifier public and then followed by the name of the superclass, which is vehicle here. So I'll copy and paste it here. Now what I'm going to do is, first of all, I'm going to create an instance of the superclass, which is vehicle. So I'll copy this. I'll go to my main method here and I'll say vehicle v1. With this object, I can call the method this method. So let's do that first. Now I'll say v1 dot method name and let me run this program and see the output. And as we are aware that this particular object v1, once it is created, it will call its constructor. This is the default constructor. So first we'll get this as an output. This is vehicle. And finally, when the method is called, we'll get this as an output. So let me run this program. I'll say build, I'll say run, and I'll say build and execute. So let us go and see the output here. So it is saying this is vehicle, which is coming from constructor, and this is display vehicle, which is coming from the method call. So this I have to close. This is my earlier executed output. So from this program, we got output as first this one from constructor and then this one from the method. Now what I'm going to do is, let me comment this. Now I'll create instance of subclass, which is car. So let's go ahead and do that. I will create object of this C1. You can give it any name and then I'll say C1 dot. So you will see now it gives me an option to call both the methods car, and let's also call the other one as well. I'll say display. Let me delete this and I'll say vehicle. Now, because of inheritance, what has happened is the member which is in the superclass here, the vehicle, it gets inherited in this class publicly because we have used public access modifier, and therefore with the instance of car class, I can also call this particular method display vehicle. Now, one important thing to note here is that when an object for the class car is created, so it in turn extends vehicle, right? So the hierarchy is like this. This is my vehicle and this is my car. Let me represent inheritance by this way. So car is extending vehicle. Now, when I'm creating an instance of a class car and this car is extending a vehicle, it is necessary that before I can create an instance of car, the vehicle instance should be existing. Meaning that if car has to exist, vehicle should also exist because car is extending the class vehicle. So when you create an object of car class, what will happen? It will come to the constructor of the car here and it will see that this car extends another vehicle. So first of all, it will go to the constructor of the superclass, which is vehicle in this case, and it will display first this is vehicle, then it will come back and display this is car. So the order in which the constructor will get called is the one from the superclass is called first and the one from the subclass is called later. So as an output, first we'll see this one, then this we'll see output 2. And after that, depending upon the method call, then you're calling display car and then display vehicle. So then it will call the display car output and display vehicle output. Okay, let's try to run this program. I'll say build and run and let's see the output. So I'll go here in the output window and see, you will see this is vehicle, this is car. So this vehicle is coming from superclass constructor, then subclass constructor. Then I'm displaying car here, as you can see at line number 45 here, this one, and then display vehicle. So this is the order in which the execution will happen. So basically first the superclass constructor, this is superclass constructor, subclass constructor, then the method call, which we have done explicitly at line number 45 and 46 in this particular example. So basically this is how the concept of inheritance works, wherein a class can extend another class with an access modifier specified here. And this concept is single inheritance concept. Then next is multiple inheritance. So what happens in multiple inheritance? The process of deriving a new class which inherits the attribute from two or more classes is known as multiple inheritance. Now here you have a vehicle. a vehicle could be inheriting a car and a bus and a train, maybe, for example. This is a hypothetical scenario or an example. So maybe vehicle will get the attributes or methods of car and also bus and also train. This concept is known as multiple inheritance. And syntactically, you say class. So you already have the three classes, superclasses. Then you say class vehicle colon. You specify the access modifier and the name of the superclass, comma, again access modifier and then the superclass bus, and then again access modifier and the superclass train. Now, what is the significance of this access modifier? This has already been covered in a different module, access modifier. Please feel free to refer to that module. But for now, we are talking about a single class inheriting methods and attributes from multiple classes, which is a concept of multiple inheritance in C++. So now let us look at coding example for multiple inheritance. So here I have one class with a constructor and another class with a constructor, right? Now what I have to do is syntactically, as you can see in this slide here, I'll say colon public, the other car and the other bus class. So let's go back here. I'll say colon public vehicle, let's say, and then I'll say comma public, again access modifier and four-wheeler. So basically what we have done is this particular class car, as you can see in this case, extending vehicle as well as four-wheeler. So this is a concept of multiple inheritance. Now let's come back here. Now let's try to put some code in the main here, and we will put some code here in the main. Now what I'm doing here is I'm creating an object of subclass which is car. And we have seen in the previous example that because car is extending vehicle, so first of all, the constructor of vehicle will get called and it will display this is vehicle, and it will then also display the constructor from four-wheeler. So if I run this program, we should see output from the superclass constructors. So let's do one more thing. I'll create one more constructor here and I'll call it car, public access modifier. I'll say car, and here I'll say cout, this is car, this is car, car, and I'll say endl. Now let us try to run this program. So first of all, we'll get the call to the constructor from the superclasses and the subclasses. So let's go to build, let's go to run and say build and execute, and let us see the output. I'll go to the output window and you will see that first we say, see the output as this is vehicle, then this is four-wheeler vehicle, and this is car. And as I have already explained, because car is extending vehicle, so it will give output from constructor of the vehicle class, then from four-wheeler, and then the car class constructor is called. So this is how the concept of multiple inheritance works in C++. Then next is hierarchical inheritance. The process of deriving more than one class from a base class is known as hierarchical inheritance. So we have more than one class, as you can see, which is extending or inheriting from a vehicle class. Syntactically, you create a class, and then what you can do, there is a class which is extending vehicle, car is extending vehicle, bus is also extending vehicle. So this is a concept of hierarchical inheritance in C++. Let's look at this with an example. So let us look at coding example for hierarchical inheritance. So I have a vehicle class, then I have a car and a bus class. So here I'll say colon public vehicle public vehicle VHI. And then here also I will say colon public and then vehicle. Now, if you will see, this is what we had done in hierarchical, that we have different classes which is extending the same superclass. Same thing I have done here, class car and bus extending the same superclass vehicle. Now, if I go ahead and create an instance of car, so let's say car I'll create. So car, I'll say C1, maybe any name you can give, and then I'll say bus B1. So what this will do is when I create an object of car C1, it will come here, which in turn will call the superclass constructor. So you will get this as an output once, and then finally, because of the second bus B1 object creation, again you will get the output as vehicle. So let us create one more constructor here. First, I'll specify the access modifier public colon, and let's say I will call it constructor here. I'll say cout I am car endl, and then let me also, I'll just copy and paste all of this, and I'll just change the name in the subclass here in the bus. So let me just copy this here, put it here, right, and I'll put this here as well. So now we know that when I'm creating C1, it will come to this constructor, display this, but before it displays this, it sees that it also has a superclass vehicle. So I'll copy this and correct this. This is vehicle here. So it will go to the superclass, first display I am vehicle, and then it will display I am car. And then from the next statement, bus v1, it will come here. It sees that it has a superclass. It will go to the superclass constructor and display the value from superclass constructor, and then finally display the value from this constructor, right? So let us see the output of this program. So as you can see that first of all, I get an output. This is vehicle and then this is car. And then finally, this is again vehicle and bus. So this is coming from first object and this is coming from second object. So this is how the concept of hierarchical inheritance works in the case of C++. The next is multi-level inheritance. As the name suggests, there are different levels. If I call this as level 1, 2, 3, then 3 extends 2, which in turn extends 1. So the process of deriving a class from another derived class is known as multiple inheritance. Syntactically, car is extending four-wheeler, so this one, and four-wheeler is extending vehicle. So what will happen, the attribute which is here, let's say there was an attribute, public attribute A, variable A, which came here. And if you have publicly extended the class, then as you can see, I have used public keyword here, then A will be available from vehicle to four-wheeler. And again, if we are doing public inheritance, this again will be available here. So this way we achieve multi-level inheritance in C++, meaning that depth or the level of inheritance is when one class is extending another class, which in turn is also extending another class. So this is a concept of multi-level inheritance in C++. So let us try it out with an example. So here I have three classes, as you can see. I have a vehicle, four-wheeler, and a car. So let us begin our inheritance. In this case, we'll talk about multi-level inheritance. So first I will go to four-wheeler and say colon public vehicle, and then here I'll say class car colon public, and then I'll say four-wheeler. Now if you will see, what I have done is hierarchy has become something like this. So I have a superclass, subclass, and another subclass here, right? So if this is my vehicle, this is my four-wheeler, and this is my car. Let me erase this. So coming back. So what I'm doing is if I create an object of this class, which extends this, which in turn extends this. So this will first call this constructor, this will call this constructor, and this is how it works like we have seen earlier. So let me go and create an object of car. It will come here, and then it will come here, this constructor, and then it will go here. So first of all, it will display the value from vehicle, which is this is vehicle, then from the four-wheeler, and then finally from the car. So let's try to run this program and see the output. I'll go to P1 here, and this is vehicle from supermost class, then object with four wheels are vehicle, car with four wheels. So this is how the output is generated. Now also whatever you define in the topmost class, so let's say I define a method here, void method cout. I'll display here, this is method from CL, and then here I'll say endl. Now what happens is when you have the supermost class A, B, and C, and inheritance is involved, so what will happen? This will inherit, or rather the methods and attributes from A will get inherited in B, and from B it will get inherited in C, since we have made use of public access modifier. To know more about this access modifier, check out the module access modifier. So if I've defined a function here, method, and I'm publicly inheriting it in this B class, which in turn is being inherited by C class, then I can create instance of CC and then call that particular method, which is this particular method. So let's try to call this method and see the output. So what I have done here is I have created an object of car class, which is the one at the bottom in the hierarchy. And then I call this method, and this method is basically, if you will remember, that it is in the topmost class in the hierarchy, right? So with the object of the subclass, I'm calling the method in the topmost class. So let me run this program. I'll say build, I'll say run, and then I'll say build and execute. And let's go to this window and see the output. So you can see that I'm able to display this is method from vehicle. So this is how the method from the superclass will get inherited in the subclass down in the hierarchy. So this is how the concept of multi-level inheritance works in C++. Then the next one is hybrid inheritance. As you can see, the combination of more than one type of inheritance is known as hybrid inheritance. So you have basically a car and a bus, which are actually vehicles. So car is extending a vehicle, bus is also extending a vehicle. car is extending a vehicle here. As you can see, car extends vehicle, and bus is also extending a vehicle. Now you have a fare class, which in turn is extending car and a bus. So basically this kind of inheritance which is available in C++ is known as hybrid inheritance. Now, as I have already told you, you might be curious to know that which one to use when. So as such, there is no specific rule or guideline, but depending upon the problem statement that you are trying to solve, you should use either one of them. So for example, let's say if you have this particular inheritance, let's say multi-level. So this is a nice example. So you can have a vehicle at the top in the hierarchy. Under that, you can have a four-wheeler. Under four-wheeler, you can have a car. Under car, you can go to one more depth, which is, let's say, Maruti, for example. Similarly, under vehicle, you can have two-wheeler also, two-wheeler. Here you can have bike. Underneath, you can have different brands of the bike. So this is basically you are trying to achieve multi-level inheritance. So this way, depending upon the problem statement that you are trying to solve in your program at any given point of time, you have to decide to choose a most suitable inheritance concept to solve your problem. So let us look at an example to understand that. So I'll go to my VM here. I have a class here, vehicle. This and this is extending vehicles. So diagrammatically, if you want to draw it, this is vehicle. Then I have car and bus, which is extending vehicle. And then finally a fare class, which is extending this car and bus. And then finally you can create instance of fare or whatever class, and the conceptual working of the different calls to constructors and method remain same as I have already explained. So these are different ways how you can use inheritance in C++. Now, what are some of the advantages of inheritance? So basically, the main advantage of inheritance is that we reuse the existing code that might have been created by other developer. So as I had told earlier, you have something in place. So let's say you are trying to construct or build a new car. So you don't want to build a car from the scratch. Let's say there was already an existing car features or functionalities available. Then you are creating a new car, and let's call it, for example, Zoom car. I mean, Zoom, we already know is available as a rental car. So if you are trying to create Zoom car, what you can do is you can take the existing car, extend that, and maybe you can add more additional features, functionalities. So basically we reuse what is existing. That is the emphasis or the main concept of inheritance. As the name suggests, inheritance means you inherit what is existing or what is already there. Like you inherit features, attributes from your parents. Now the child class can inherit superclass to reuse what is existing and add newer functionalities to the base class to enhance, upgrade the existing functionalities. So as I said that when you inherit, you get what is available in car. Of course, what you get will depend upon the access modifier in this class. This concept of access modifier I have covered in a separate module of access modifiers. Please refer to that. But what is there in car you get in Zoom, and plus additionally you can add new features that you want to enhance a car class and then build a Zoom car of your choice. For example, BMW might extend a car class and enhance it to its engine power in subclass to give a better performance. So as I have already told you, we are basically trying to achieve reusability and then extend the functionality by adding more features and functionalities in the subclass. So these are the major advantages of inheritance in C++. So what is hex overview? So this concept involves basically the conversion of natural number to hexadecimal, or rather radix 16 or base 16. So there is an inbuilt function that is available in C++, which is std::hex. The function std::hex is used to set the base to hexadecimal. So basically, to understand this, I will bring up browser here from Wikipedia. So I believe you will remember from your school days, college days, that we can have a number represented in different forms. So if this is a decimal number, its hex is 0. Like this until 9, the hex value is 9, then 10 is A, similarly B, C, D, E, until 15 is F, then 16 becomes 10, then 17 becomes 11. So basically, how is 17 becoming 11? So you take 17, you divide it by 16, it goes in 1, and remainder is 1. So we represent 1, 1, which is equals to 17 to the base 16. Similarly, if you have another number, here now I have 54. So how does 54 work? So I'll take 54 divided by 16, 16, 3, 48. Then I have remainder 9, 50, 51, 52, 53, 54, 6. So then I represent it as 3, 6. And if I have to convert it back to decimal number, or rather to the base 10, so in that case what I do is I take this number and I say 16 to the power 0 into 6 plus 16 to the power 1 into 3, which translates to 54 to the base 10. So this is how we do hexadecimal conversion from decimal number to hex number. So we have basically some inbuilt functions to perform these operations for us. You don't have to evaluate it. So let's move on to the next slide and see some other examples. So like hex, we have method for finding octal, decimal, hex number, right? So if you will see here, decimal will represent decimal number which is coming out to be same. So similar is the case of octal decimal number. Consider the following. So you have octal, hex, decimal. This is a decimal number to the base 10. Now if I represent octal, it will be the value 142. Decimal will remain the same, and then hex will become 62. So we know that we can convert 62 back to decimal by saying 16 to the power 0 into 2 plus 16 to the power 1 into 6, right? So we'll get back our decimal number. So this is how we can convert a decimal to hex and vice versa. And there are inbuilt functions provided to do this. You don't have to write logic to do that yourself.
So now this is my VM where we are going to try example for hex. So I have defined an integer. As we have already seen in the slide, I can simply say cout and I can say hex, and then I can specify that number and here, right? And let me end it with ndl. So this will go ahead and display the hex equivalent of 54. I have already explained to you how we evaluate the hex while discussing in the PPTs. So I will go to build, I will go to run, and then I'll say build and execute. And here in this window, you can see the equivalent hex value, which is coming out as 36. Now, like hex, there are a few other functions also available when we are making use of namespace std. So if you want to display octal value, and then if you say DEC, it is the decimal or the base 10, which is same as 54 itself, DEC. So this will display hexadecimal, octal, and this will display decimal or to the base 10. So this is going to be 54 itself. So let's run this program and see. Build, and then I will say run, build and execute. Let me go here and see the output. So you can see the different values of hex, octal, and decimal values being displayed by inbuilt functionalities that is provided in C++. So basically this is how hex works in C++.
Now let us look at a tic-tac-toe game. I mean, we all have played a tic-tac-toe, so we will try to understand the rules to play this game, and then what is winning and losing condition or and draw condition, and then we will write a implementation for this. So this game is to be played between two players. One of the player chooses 0 or O, you can call it, and other as X to mark the respective cells. The game starts when both optimally make them move one by one. The game ends when one of the player has completed the row, column, or diagonal marked by the respective characters. If no player wins, the game is set to draw. So I believe you all have played this game earlier in your school days, college days, or maybe now as well. So suppose player 1 marks X and player 2 marks O's, right? Here the player 1 chooses the character X and player 2 gets the character O. Since the player 1 has marked all the diagonal elements, so this is a diagonal element, all marked as X, so the player 1 wins in this case. So this is a winning condition in a tic-tac-toe program. Now moving on, this is a case where it is a draw where nobody has won the game. So we don't have any horizontal or vertical or diagonal completion of the similar characters. So we will try to understand and implement this particular program or game with the help of C++ coding as well.
So let us look at tic-tac-toe programs. So basically, we all have played a tic-tac-toe program where we have these two vertical lines here, two horizontal lines here. Now there can be two players, so one player can put a cross here, another can put a circle here, cross, circle, and cross. So this player who has got all the cross in this diagonal rather, is winning. Or anybody who has the same sign either in horizontal, there should be 3 of them, or vertical, he or she wins the game. So we all know the rules, they are very simple. So here I have a main method and I have a do and a ending while here, right? Which runs until we have I equal to -1, right? Then I have a board method I'm calling. So if you will come down here, this board method displays the board. The board which I just showed to you, this will be displayed here. And then this is basically a function which returns game status. If it is 1, 1 for game is over with result, -1 for game is in progress, and 0 if it is over and it has no result. So let's try to run this program, a very simple game to play. So I will go to build, I'll say run, I'll say build and execute. And if you will go to this window here on the right side, now this is how the tic tac toe looks like where we have a player 1 who can put X as his move and player 2 who can put O as his move. Now you can enter a number. So player 1 enters a number, meaning if he enters 1, he will put cross at 1, as you can see here, right? Now player 2 enters a number. So if 2 enters a number, let's say he chooses 2, and you can see here, right? Initially it was X, now for player 2 it is 0. So like this, you can continue. A player 1 enters 3, for example, 4. So like this, you will keep entering your choices, 6 and 7. So you can see that player 1 has won the game. So these are all X here. So he has won the game because this diagonal is completed. So this is the how you go about implementing this particular simple game, rather tic-tac-toe. So when you continue with this game for different options, you might end up into a draw, you might end up the player 1 winning, player 2 losing, or rather player 2 winning, player 1 losing. So these are different options that are available while you run this program or play this program using the C++ implementation. So that's all we have in this tic-tac-toe program implementation.
That's all in this discussion. Thank you so much for your time.